Hi students, let's look at this question here, which is on the application of differentiation. Let's say I can do this proficiently. So you're given a circular cone with the base radius r, or the curved surface area is pi r and volume is 1/3 pi r square h. Okay, that's pretty okay. Now a capsule made of metal sheet of fixed volume p. Now this is fixed, so take note of the fixed constant here. It's made of this, made of 3 parts. Okay, so this case here, what we need to do is the top is modeled by a curved surface of radius cone of radius r. The ratio of the height to its base is 4:3. So ratio of height to its base radius. Okay, that's pretty okay. So the height here, the small height here, this is height. So label this out first. H over r is 4/3. Okay, so meaning this is h is equal to 4/3 r. The body of the model by the curved surface area cylinder radius r and height h. Okay, so is also r here. And base model by a circular radius of r. The base model is a circular disc of r. Okay, so there's a disc here. Okay, so this is a capsule. There's a base area. There's a curved surface area of the cylinder and the cone. So show that h is given by this. Okay, so the cost. Okay, assume that there's made shear negligible thickness. Okay, great. So I think the cost has nothing to do with this one, this h here, because now what you need to know is actually there's a fixed condition here. The fixed condition here follow what we have in our summary notes. So take note here. So in this case here, always know that there are 2 variables at play, which is x and y, typically in the question. Then there's a fixed condition. Okay, so in this case, the fixed condition here is actually PCM cube. Then the 2 variables will be this r and this h here. This r and this h here. So these are the 2 variables, right? Because this small h here is actually in this ratio, so it's okay. So this r and h are the 2 variables. So the 2 variables are r and h. Volume is actually a p. So we're gonna write this down. There you go. So the volume. So part 2, volume of the whole thing. Volume of the capsule of volume is actually p, which is actually 1/3 pi r square h, which is the volume of the cone. Okay, this small h here, and then after pi r square big H plus pi r square big H. So this case here, once done, we know that the small h is just now we did, which is 4/3 r. So this is 1/3 pi r square. Was it 4/3? 4/3 r. Here will be 4/3 r. Then this will be pi r square h, and this will be p, right? Now once you have that, what you're gonna do next is we're gonna basically just gonna find h, right? So make h a subject. Because h is in terms of r, you see this is r. So we already have np, yes. So this case here we'll get is 4/9 pi r cube plus pi r square h p. So I'm going to divide both sides by pi r square. So this is pi over pi r square. Also 4/pi r cube over 9 pi r square plus h. Okay, so it's very quickly we can actually deduce what is h there. So h here, h will just be p over pi r square minus of 4/9 r. Okay, they want the r above, so just leave it as such. There you go. So let me just write this down for you. Divide by pi r square. Divide by pi r square. Okay, good job. There you go. So let's look at C, part 2.